right? Arithmetic progression, which is commonly called AP, and then geometric progression, which is uh, GP, right? So technically, this unit is going to be will introduce us to the concept of sequence and series and give some examples of each, right? Now, when you go through this course, you're going to recognize the difference between a sequence and then a difference between a sequence and a series. You're going to be recognizing arithmetic progressions. Then you can find the end term of the arithmetic progressions. You can find the sum, and then you're going to recognize a geometric progression when you see one. Then you're going to find the end term. You're going to find the sum of a geometric series. Then you're going to understand how to find it to the sum to infinity. Likewise, before I continue, you can always get this material from Math Center in the UK, or you can get a similar document anywhere online to follow up with this course. But if you want this particular document, you will just go to the comment section and comment, subscribe, then I will send this to your inbox, right? Now, the content for today is going to be series, sequence, arithmetic progressions, the sum of arithmetic progressions, geometric progressions, the sum of a geometric progression, then convergence of a geometric progression, right? So now, what's a sequence? A sequence is just a set of numbers which are written in some particular order, right? Um, for example, let's take this number 13579. We all know that this number somehow they are arranged in an order of in ascending order, and then there is something unique about this number. The difference between this and this and this and this and this. You can see that we can call this sequence a sequence of odd numbers because there's no even number there and they are progressing. Now, to put this away, we can start with number one, which is an odd number, and then each successive number is obtained by just adding 2 to it. If you notice, 1 when you add 2 is 3, when you add 2 is 5. Now here's another one: 1, 4, 9, 16, and 24. This is just like saying you have numbers that are perfectly squared, right? Now, like 2 square is this, 2 square is this, and 3 square is 9, 4 square is 16. You can see that is a sequence. It's a sequence because they are arranged in a unique order and they are ascending, right? This is a sequence of square numbers. And this sequence, can you see 1 minus 1, 1 minus 1, 1 minus 1, is a sequence of numbers alternating between 1 and minus 1. So in this case, the dot here means that it is going all the way to infinity, right? The dot here means that it is going all the way to infinity. So when you say something is going all the way to infinity, what does that mean? It simply means that you have positive infinity, or you can see it infinity, right? Infinity. But this is a symbol for infinity. Are we together? Now, if you look at this clearly, you can see that on the other hand, the number 1, 3, 5, 4 form a finite sequence because you can count them, right? So when you did not see those three dots, if you're into anywhere in your textbook, in your math assignments, in your science classes, when you see this, we call it C dots, right? So this is just trying to tell you that you have a sequence, but it is either finite or infinite. In our case, it is a finite sequence. Now, let's continue. Where you have those sequences that are finite and infinite, this is how they look like. Now, this is a finite sequence, but when you see the ones without with and dot continuously, it's telling you that it is infinite. Now, then this sequence, for example, take this sequence for instance, it is called a Fibonacci sequence. A Fibonacci sequence. It is obtained by adding together two previous terms. It is obtained by adding together two previous terms, like 1 plus 1 is 2, right? Then 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on and so forth. Now, This sequence, another example, we could use this notation to represent the rule for the Fibonacci sequence. We can use the term u1 un is equal to un minus 1 plus un minus 2. Now, like we said, sequence, you can represent them using un for the last term, u1 for the first term, u2 for the second term, u underscore 3 for the third term, right? So if I want to get this particular third term and is in the Fibonacci, if it is a Fibonacci, it's very simple. Why? All you need to do is, right, we have u1. If we have u1, so all we need to do is to take out one from the first term and take out the other from the second term, and that is that about that. So key point here is that a sequence is a set of numbers written in an order. We sometimes write u1 for the first term of the sequence, u2 for the second term, all the way to un. Un is going to be for the what? For the nth term. Un is going to be for the nth term. So you're going to be taking some little exercise. Good. Now let's take on some exercises, right? Some exercises. We have a sequence is given by, for instance, a sequence is given by the formula un is equal to 3n plus 5 for n is equal to 1, 2, 3. Is this a finite sequence or an infinite sequence? It is infinite because of this, right? See, that is continuous. So write down the first 5 terms. So which means I'm going to have to get what is u1. So u1 is technically going to be what? 3 into 1 plus 5. 3 plus 1, 3 into 1 plus 5. 3 multiplied by 1 is 3 plus 5 is going to be what? It's going to be 8. Right? So this is going to be 8. Right? That's that about that. So subsequently, we're going to be looking for u2, u3, u4, u5, and then you're going to be writing them down, and that become your sequence of number. So for instance, u4, if I want to get like u4 is going to be what? 3 into 4 plus 5. That's u4, right? So this is going to be 3 multiplied by 4 is going to be 12 plus 5, which is 17. Good. Now a sequence is given by this un is equal to 1 upon n squared, right? So how can I get that to write down the first term? What is the 10th term, right? What is the 10th term? So if this is the formula, I can just say that we have u of 10 is going to be what? 1 over 10, right? All squared, right? This is going to be 1 all over 100. Now, write down the first 8 term of a Fibonacci sequence, un this, when u1 is 1 and then u2 is this. The first 8 terms. You can do that. It's pretty simple. Like if you want to get, the formula says you have un is equal to un minus 1 plus un minus 2. So if that's the case, if I want to get u, for instance, let's say u of 4 is going to be what? U of 4 minus 1 plus u of 4 minus 2, right? So this is going to be what? u of 4 is going to be what? u of 4 minus 1 is going to be 3 plus u of 4 minus 2 is going to be 2. So you can see that for every Fibonacci sequence, it is the addition of the two previous sequence. Similarly, if you want to do for u, let's say you want to get u of 2, 3, for instance, is going to be u2 plus u1, and so on and so forth. Now, you can see that clearly it is very simple, and then you can always get it done. Now, a series, we have talked about a sequence, right? Now, a series is thing we obtain from a sequence, right? By adding all the terms together. You have a sequence. Sequence is just a set of number properly arranged in ascending order or descending order, but it is arranged. A particular number has a unique identity but can be obtained from a previous number. You can call that a sequence. Now, when you add them together, when you add those terms together, it is now called a what? A series. So the idea is pretty simple. It's called a series. Now, you can now say that if I have this as a sequence, 1, 2, 3 up to n, right? Now, then S1 is going to be 1, right? As it is the sum of just the first term. Then the sum of the second two is going to be what? S2, right? S2, which is 1 plus 2, right? Then S3 is going to be what? 1 plus 2 plus 3. Then S4 is going to be 1 plus 2 plus 3 plus 4. Mind you, clearly what we're trying to say is that if I have 1, comma, 2, comma, 3 all the way, my series is going to be what? 1. Then the series is just adding them together, right? 2 plus 3 all the way. So if I'm adding S2, is going to be, what is the first two term? What is the sum of the first two term, right? This is going to be 3. If I have S3, what is going to be the sum of the first three terms? It's going to be 1 plus 2, 3 plus 3, which is what? 6, and so on and so forth. Good. Now, technically, if you look at it, a series is a sum of the terms in a sequence. If there are n terms in a sequence and we have evaluated the sum, then we are going to obtain S10, which is going to be the final sum. The Sn is going to be adding all these terms up to n. Good. Now let's look at some clear exercises over here. Now, you see, write down S1, S2, and Sn for this sequence, right? It is finite. Why? Because we just have 1, 2, 3, 4, 5, 6 terms. So we're going to get S1, you can get S2, you can get S3, S4, you obtain S5, then S6. Are we together? Then now what you're going to get is you're going to get 1, but for this guy you're going to have 1 plus 3, which is going to get you 4. For this guy you're going to have 1 plus 3 plus 5, right? 1 plus 3 plus 5. That's the first three terms. And this, I think, should give you 9, right? So on and so forth. This will give you 1 plus 3 plus 5 plus 7, which is going to give you what? It's going to give you 16. And then you go on like that. Similarly, you can do the same for this, right? So now, a arithmetic progression, consider these two common sequence. This is now talking about a sequence. This is a sequence and this is another sequence. What can you observe? You can see it's easier to see that it is forming a sequence. This is a sequence. That is something different. Now each starts with a particular first term and then it gets to progress with terms by just adding a fixed value from the previous term. I know if I add a value here, I'm going to get this. In this case, it's 2. If I add a value here, I'm going to get this. In this case, it's 10, right? This is 10. So by so doing, we can say that we could also just subtract a constant term because it is just the same as adding a negative constant. For example, in this kind of sequence, you see, we have 8, 5, 2. We can see that it is diminishing. By the time we are taking out, we are adding minus 3 to each term of the sequence. It is diminishing. So any sequence with this kind of property is called an arithmetic progression. You understand? Then you call it AP for short. You have a set of numbers. You can always take out a particular constant and then you are going to get the previous number, or you add a particular constant, then that particular sequence is called an AP. For instance, we have 1, 3, 5, 7, and 9. You can see clearly that 1, 1 plus 2, 1 plus 2 times 2. Then you can see that this sequence is very, very clear. Now we can write it in this form of A plus D, where D now is the difference between the two terms. We call it, let D stand for the common difference. So if D is the common difference, when you take out two consecutive progressing or descending order, the difference is called the common difference, and it must be unique. That's the difference between here and here should be D. The difference between here and here should be D. The difference between 7 and 5 should be D. The difference between 9 and 7 should be D. So in this case, you can write it in this term. So if by so doing, since we know that A is the first term as represented here, in our case, the D is equal to 2, which is called the common difference, right? So we want to write down this particular n term. So to obtain any n term, right, to obtain the n term is very clear that all we need to do is to write A, which is the first term, plus n minus 1 D, right? So it is very simple. We have A. If we want to get the nth term, right? The nth term, the nth term, the nth term is going to be what? It's just going to be A plus n minus 1, n minus 1. Then you have your constant D. Remember, this one is your first term. This is the first term, right? Why this becomes your what? Common difference. So if you have the common difference, and then you have your first term, then you're good to go. You can use it in every other part of arithmetic progression. So this is the key point. An arithmetic progression, AP, is a sequence where each new term after the first term get is obtained by adding a constant D, which is called the common difference. In our case, you should be familiar with this. A plus n minus 1 D. So can you see, like, write down the first term, the first 5 term of this AP with first term 8 and common difference 7. So if the first term is 8, the first term we know is 8 and the common difference is 7. So the second term is going to be what? 7 plus 8. 7 plus 8, which is going to be 15. The next term will be 15 plus 7. 15 plus 7. So this should give us, I think, 22. Then plus 7. This will give us 29, and so on and so forth. Right? Write down the first 5 term of AP with first term 2 and common difference minus 5. So for this we have first term is 2, common difference is minus 5. Take out minus 5, we get minus 3. Take out minus 5, we get minus 8. Take out minus 5, and so on and so forth. Find the seventh term of the arithmetic progression with the first term 5 and the common difference is equal to 2. This kind of question is very, very unique, right? Now we have the first term and the common difference. So we're looking for the 17th term. The 17th term, right? 17th term. So this is going to be first. We know that the formula is going to be A. For nth term, we know is A minus A plus n minus 1D. So 17th term, we're going to, first term is what here? First term is 5 plus into the nth, the n is 17 minus 1, then the common difference is 2, right? So this is going to be 5 plus 16, then multiply by 2, right? So if that's the case, we're going to have, lastly, this is going to be 5 plus 16 multiplied by 2. This should give us 32. Then this is going to be just 37. So that's that about that. You see how simple it is. So you can actually write down the 10th term and the 17th term of this particular AP. So the first term is 8. Now what is the common difference? Common difference should just be here 3, right? Because 3 plus 8 is going to give you 11. 3 plus 11 is going to give you 4. Similarly, you can check what is it here. Here you have 8 and then 5. So definitely it's going to be minus 3, right? The common difference is going to be minus 3, while the first term is going to be 8. Now this one is this, right? This one is an AP is given by k, 2k over 3, then k all over 3, then you have 0 over here, 0 over here. So what are they taking down? You can always find the system, find the end term, which we are going to be doing from the next video. Then we're going to be going into sum of an arithmetic progression, the sum of an arithmetic progression. So stay tuned. We are going to be continuing from the sum of an arithmetic series. Now you can watch the previous video or the next video for clarification, and then stay tuned to this channel to get this done. We are halfway gone into AP. Then we're going to be discussing GP at the end of this video.